Hi, can you hear me? Okay. So 2 years ago, I was here on this stage to talk about what Rust can offer you. And today, I'm here to talk about Rust again, but this time from a completely different perspective. My name is Jakub Bera. I teach at this university. I do research at the National Supercomputing Center. But my main job is actually being an open source contributor. And mainly, I contribute to the Rust project. I'm a member of the Rust compiler team, of the infrastructure team. And recently, I was selected to be a member of the Rust Leadership Council, which represents the project as a whole and is a top-level governing body. So today, I want to show you how we do governance, development, deployment, and maintenance in Rust, all with the power of open source, and how we use various tooling and bots to make our lives easier. So let's start with governance. That's such a weird word to say at an IT conference, right? Like, what is that? Governance is a decision-making process designed to evolve something, like a country or a company. But today, I'll be talking about evolving programming languages. I assume that a lot of you are programmers and you have some favorite programming language. Have you ever thought about what it would take to change that programming language? It depends a lot on what is the governance model used. So, for example, if you have a language like C#, TypeScript, Golang, or Kotlin, which is backed by a big company, probably the only way to change that language is to get hired by Microsoft or Google, which is, not impossible. I know people that work in those companies, but it's also not very easy. Another approach is to have languages designed by a committee, like most infamously C++, but also C or ECMAScript. And if you want to change something in C++, you need to go through the ISO standardization process. I talked to some people that did this, and this is how it works. Like, you need to get to a private mailing list. You need to request a paper number. You need to write a paper with your proposal. Then you need to address the right study group. You need to send it at the right time. You need to make sure that it gets to the study group. You need to find a champion. You need to attend a committee meeting personally, which can be quite expensive. Then, if it's OK, it will be sent to another study group. If it's not OK, you will need to go back to the drawing board and repeat this process. And then, if it finally gets accepted, you need to wait about 1 to 3 years before it gets to the next standard and before it gets implemented in a compiler, right? So this is a very slow and tedious process, and it is by design. It's an ISO standard after all, but if you are a C++ programmer and you want to change something in the language, it's not very easy. Yet another model is a BDFL, right? That a single person has all the power about the language. This was popularized in Python, but it's also used in Zig or Ruby. And if you want to change something in those languages, I guess you need to become a friend with BDFL. You need to convince them that your idea is the right one. And the last model that I will be showing is the one I like the most, is the open source RFC process, which is used by Rust, PHP, or Python. And to propose a change, you just send an RFC. You write it, you publish it to a GitHub repository usually, and anyone can do that. And if you want to gain voting rights, you usually need to contribute so that you gain trust of the maintainers, and then they will allow you to actually vote on those RFCs. So with that, let's take a look at the evolution of Rust governance. Rust started in 2006 as a personal project by Graydon Hoare, who was working in Mozilla. So it started as a BDFL project, right? Then he took it to Mozilla, and a few people started working on it. A few years later, the first core team was established, which was about 5 people from Mozilla that had all the decision powers about the language. Then Graydon actually left the project because he kind of burned out. He didn't want to continue anymore. So here the BDFL era ended. And the RFC era started the next year. Rust adopted an RFC process that was inspired by the Python extension proposals. And someone was actually very eager about this process. So the first RFC is actually a language change about some structure fields. And only the second RFC actually defines how the RFC process looks like. So you can see here that the RFCs are used both for technical and non-technical changes. The year later, the Rust 1.0 was becoming stabilized, and it became clear that a single team cannot scale anymore. So a set of 5 initial teams were established to split the responsibilities. Teams to develop the language and the standard library, teams to maintain and develop the compiler, the infrastructure team to develop tooling, CI, and so on, and the moderation team to make sure that our code of conduct is being upheld on forums and social media and so on. Now, this was working fine for a few years, and those people were paid by Mozilla, but Mozilla didn't actually have any, I would say, large influence over the language. But in 2020, Mozilla kind of ran out of money, and they couldn't afford to pay those people anymore. So Rust had to become self-sufficient very quickly. So the next year, the Rust Foundation was established, which is a non-profit organization designed to support the project. And sadly, right around this time, we also ran into a set of like Rust dramas that were very public online because we do everything in the public. For example, the moderation team resigned after some personal conflicts with the core team. The Rust Foundation published a trademark that was very controversial and was like ridiculed online. And it even led to some fork of the language being created for a few months. Right? And there were a bunch of other missteps. So as an attempt to like improve this situation, it was clear that having a core team that has like all the power about the project is not a good idea. So we replaced the core team with something that we call the Leadership Council. And the difference is that the Leadership Council doesn't really have any administrative privileges. They just delegate all the decisions to the other teams, and they mostly just represent the project itself. So how does it look like today? We still have those original top-level teams, library, moderation, infra, language, and compiler. We have two others. One is the DevTools team, which manages things like the build tool, linter, formatter, and so on, and the launching pad, where we just kind of put the things that we don't know where they belong. And every one of those teams has a representative in the Leadership Council. So, for example, I'm a representative of the infra team. But it's not just those like top-level teams. The hierarchy goes much deeper. So there are various sub-teams, working groups, project groups, and so on. And this whole thing together is what we call the Rust project. Right? So this is a set of about 300 people that I work with those people almost every day. I never met a lot of them. I might not even know how they look like or what is their name. But we all work together to develop, maintain, and govern the Rust programming language. Then there's the Rust Foundation, which provides the legal stuff, pays for the infrastructure, owns the domains, trademark, does some funding. And then there are hundreds or thousands of other contributors that contribute to Rust, but they don't have any like decision power or voting rights. Right? If you think that this is kind of complicated, that's true. And we actually have tooling that helps us manage this. So this is the first instance when we use some tooling. We have a repository called Team, where we describe all the repositories and the people and teams and their structure and configuration files along with their permissions. And if you want to change something, you send a pull request, it gets merged, and then automation automatically updates all the team members, the permissions, and so on. Right? Because we have so many people distributed all around the world, we also need to communicate. So we use the Tulip discussion platform, which is something like Slack on steroids. And we can have things like named channels, which is a revolutionary feature that is not, for example, in Slack. I don't know why. But we need this to communicate asynchronously, because open source is really about communication. Like, my workday is about, like, half time I do coding, and the other half I communicate with people. I design some features, I read and write documents, and so on. And we try to make this very open. You don't even need to log in to see all the public channels. And we also try not to provide other barriers for communication. So for example, we never have like video meetings, or almost never. Most of our meetings actually happen directly on Tulip, and we have tooling that helps with this, right? So we just synchronize at this time, we will be at Tulip and we'll be chatting together, have a meeting in chat. And we have a Rust bot, which does a lot of things. And for example, it helps us manage the topics that we are talking about. Or for example, if there is like a shared document that everyone is reading, we can synchronize of whether people have already read it or not. Right. So that's the governance structure. Now, what if I actually want to change something in Rust? So what should I do? If it's a simple change, like a bug fix, performance improvement, so on, I just send a pull request. That's easy. But if it's a major change, I will need to go through the RFC process. So the Rust request for comments process was designed so that when you make a substantial change that affects a lot of stakeholders, you will give all those stakeholders a chance to publicly comment on that change. And we use them, as I said before, both for technical and non-technical changes. And we always use them for one-way door decisions, right? Those are the decisions that are incredibly hard to revert. Like if you make a language change and reverting it is a backwards compatibility breaking change, that's a one-way door decision, and you will need an RFC. So how does this project look like? Usually, before you publish the RFC, you will do some sort of vibe check on the forums or Tulip to ask, like, what do people think about it? Then you will actually write the RFC, which has a defined template. So you need to specify the motivation, why you do it, guide-level explanation, which is essentially how would you teach this new feature to Rust users, right? So we care about this a lot. Like even already when you write the RFC, you need to explain how will you explain this feature to new users. Then is the reference level explanation, which is a very technical explanation of the change. drawbacks, what are the alternatives to your approach, what is the prior art from other languages, what are some unresolved questions, and also future possibilities. We care about backwards compatibility a lot, and we need to make sure that when we make a new feature, it will be possible to modify, extend it in the future without making backwards incompatible changes. So once you do this, you send a pull request with the RFC, right? And then you will, of course, receive some comments. It is a request for comments, after all. And you can receive a lot of comments. Some of the RFCs have a lot of discussion. And actually, we are kind of overloading GitHub with this because it cannot keep up sometimes with the amount of discussions that we have. And some people even write like browser extensions that automatically click on this load more button just to see all the discussion that is happening there. And those comments can have like various shapes. Like some people can comment on the language that you use or that you had a typo. Some people like to bike shed the syntax, which is a favorite activity of all programmers, of course. And some people will just outright disagree with you. Right? And as an RFC author, your work is to gather all this feedback, integrate it into RFC, and then iterate once you reach a state that like it seems that people are happy or there is like no other discussion going on. And once that happens, we will actually initiate a vote on the proposal, right? So here we use another bot called RFC bot. And some team member will initiate the vote. And then the RFC bot will essentially track which team members have already voted on this RFC. So when does the vote end? We don't actually necessarily wait for all the votes. And we don't use majority vote. We use something that is called consensus. Consensus means that almost everyone has already voted. And there are no outstanding concerns. This is very important. Like even if the majority of the team agrees, but there is a single concern, we usually won't move forward because we want to make sure that all the voices are being heard and all the perspectives are being considered. Once the vote finishes, the final comment period starts, which lasts for 10 days. And this is essentially the like speak now or be silent forever moment, right? You can have like final comments about what is going to change in Rust. And we announce this in like the newsletter so people know about those FCPs and can have comments on them. If there are no other comments, the RFC will be finished. And this whole process can take like weeks, months, sometimes even years. It can be quite long. And it doesn't stop there, right? Like if the RFC is landed, we say, OK, we want to do this. But then you still need someone, if it's a language feature, to implement it, or you need to implement it yourself, right? So this is like one of the steps to change something, but someone still needs to do it, actually. So this was like the happy path for an RFC, but sometimes making decisions is hard. For example, in 2014, there was a great debate about how should a fundamental data type in Rust be named. Should it be uint or usize? And the core team, they examined the discussion, and then they said, like, we did some private experiments, and we decided that it should be named like this, right? But this was a bad situation because people didn't have a chance to comment on their experiments. And this actually gave rise to a new rule that we call the no new rational. And it means that whenever you make a decision, it needs to be done based on arguments that were already published before, and people had a chance to comment on those arguments, right? So that it is fair. Another example is when we were, or Rust was choosing the keyword for the await mechanism. And we had a lot of options. And the community essentially wanted this prefix option because it was used in C#, Python, and JavaScript. But the language team actually preferred this postfix variant because it had some advantages, like you could chain it. You could write future.await something. And they published some arguments about this, that it is in fact better in their opinion. Those arguments like convinced some people, but didn't convince other people. It's really hard to please everyone. At this point, people were saying like, this change is going to ruin Rust. It's just terrible. And I remember I was exactly in this camp. I was thinking like, why are they ruining this beautiful language? And someone even did a survey about like, what do people want, which syntax? And people wanted the prefix syntax, but the language team ignored that, and they just did the postfix run, right? So this landed, and did it ruin Rust? Well, it didn't, because about like 5 minutes after it landed, and people actually tried the postfix variant, they realized that it's so much better than the prefix one, that the language team was right? And I was the same. And it turns out that most of the people that were commenting online, they didn't even try the syntax. They were just like arguing about it, but they didn't even try it. So this is an example of where a team had the courage to go against the majority of the community when they were convinced that they have the right arguments, and they, in fact, did. So I would conclude this by saying that open source governance is very hard, and especially in Rust, right? Like, we have those teams that make those decisions because we cannot decide everything in 300 people. That would be impossible. But at the same time, the development is like bottom up. Every contributor decides what they want to do. Rust is not a company. We don't tell people, like, you will work on feature A, you will work on feature B, you will fix bugs. That's not how it works. At the same time, we have so many people that it's like it would be a pretty big company, right? But most of them are actually unpaid volunteers. And this can lead to things like burnout, personal conflicts, lack of transparency. So it's really quite difficult. But I would say that it's also a lot of fun, and it's very impactful, because pretty much anyone can go and contribute to making changes in a programming language, which I find like really cool. OK, so that was governance. Let's move on to development. We accepted the RFC. Now we want to build it or implement it. So usually, like, you implement something, how you land it, well, you send a pull request, of course, right? So you send a pull request, and again, you will be greeted by tooling, by Rustbot, which will assign you some reviewer, and it will tell you how you can choose a different reviewer or choose some reviewer from some other team. I think that this is very important, because when you contribute to some project and you don't get a review for like years, it's a very bad experience, right? So we want to make sure that we get the reviews out timely. It's not always possible, but we at least try to. The Rustbot also offers some other automation, like you can say that the pull request is waiting for a review, or it is waiting for the author to make some changes. And we also try to help the reviewers themselves. So for example, if you ever force pushed on GitHub, you probably know that the review UX kind of sucks. So we built our own kind of service that provides you a very nice UI about what has changed in a pull request, even if there was a force push. So we also care a lot about performance. So we have another bot called perfbot, where you can say, like, build this pull request, build a compiler out of its version, run some benchmarks, and then we will be presented with a lot of data about if the performance has improved or regressed and so on. And those benchmarks are also executed after every pull request is merged to the default branch. Once the pull request is kind of ready and it can be improved, we use another bot called Bors, and we approve it. So you might ask, like, why don't we just approve it through the normal GitHub UI, right? Like, why do we use our custom bot? Well, this rule was coined by Graydon, the original creator of Rust, and it is the not rocket science rule, which just says, like, if you have a repository, the default branch should always have green tests. I mean, that sounds obvious, right? Like, that's trivial. Well, it's not, because if you just merge pull requests, even if you have like 2 pull requests that have green tests and you merge them, their combination might not have green tests, right? So we use a bot for essentially doing a merge queue. Now, again, you might ask, why don't we just use the native GitHub merge queues? And we actually do almost everywhere, but we cannot. So first, this was used for like 15 years. 15 years ago, GitHub didn't have a merge queue functionality. It's quite new. But also, on the main compiler repository, we cannot use the native feature because it would be too expensive. Our CI is incredibly expensive. Every merge runs about 80 jobs because we build and test a lot of things for different targets, hardware architectures, operating systems. And it takes like 3 hours to run all of this. But if you multiply it by the number of runners, it's a lot of time. And if you multiply it by the number of cores, it's even more time, like 600 CPU hours just for one merge. Every month, it's like 3 million minutes of CI time. And if you multiply this by the cost, we have optimized this in the last year. But a year ago, it would be something about $50,000 each month, right? So actually, we are lucky that GitHub and Microsoft covers most of that cost. But we still need to be mindful of the cost. And the issue is that we have a lot of pull requests. And we cannot really afford to merge them one by one. I mean, we could only merge like 8 per day, right? Because we have 3 hours for CI. So what we do is called rollups, where we essentially take like a bunch of pull requests, like 10 of them. We merge them together in a new pull request. We run the CI once. And then if it's green, we merge it, right? So then instead of running the CI 10 times, we just run it once. And this saves us a lot of like money, essentially. We also care a lot about empowering new contributors, because we need new people to join the project to make sure that it will be sustainable in the future. So we have a lot of books and documentation about how to contribute to Rust. For example, this is the Rust compiler development guide, which has a very detailed walkthrough about how to contribute to the compiler. When you actually try to build the compiler, we have some tooling that setups your environment, like it prepares your IDE, it creates some configuration options based on if you want to work on the compiler or the standard library or some other things. So we try to help people as much as possible. When you make your first pull request, you will be greeted by a special message by Rustbot. It will tell you what are the instructions for a contribution, some useful commands, and so on. And we also try to help contributors with their Git issues. So we have a no merge policy in pull requests, but sometimes people push a merge commit by accident. So when that happens, we detect it, and we give them the Git commands that will essentially fix the situation, and also link them to our documentation that explains like what is a rebase, what is a merge commit, and so on. We also try to empower the contributors by giving them trust. So instead, in addition to approving a pull request, you can say that you delegate the approval rights to the pull request author, and that says like, I trust you that you will approve your own pull request. It looks good to me. We also try to remove contribution barriers. So we know that not everyone has a powerful PC, and building Rust compiler can take a long time. So we provide something which we call dev desktops, which is essentially a bunch of cloud machines, very powerful cloud machines, that the contributors can SSH to, and then remotely work on them to contribute to Rust. And we try to remove also other sorts of barriers. So for example, a lot of open source contributors have imposter syndrome. They think that they are not good enough to contribute to open source. So a few years ago, Rust published this blog post where prominent contributors to Rust actually say that they don't know just so many things. They struggle with very basic things sometimes, just to tell the new contributors that everyone struggles with something, and imposter syndrome is not something that we should really think about. We also try to, of course, thank our contributors and give them attribution. So we have a page called Thanks, where for every Rust release, we list all the contributors that contributed to it and how many contributions they made. And here we can see that over all time, over 10,000 people have already contributed to Rust, right? So it's not just those 300 people that have the voting rights, but it's actually a much larger group of people. And if you're wondering, who is the #1 contributor to Rust, it's actually the Borsbot, right? Because it actually merges all the pull requests, so obviously. But, I mean, it's a bit funny, but still, it's actually by design, because we want to say that the hardest work in the Rust project should be done by bots, right? Not by people. And if there is one thing to take away from this talk, I think it's try to build tooling and bots to make your lives easier. If you have enough people that will use them, the effect really multiplies, and I think it's a really great thing. So that was developing new features. Once we develop the feature, we need to deploy it to users, right? So how we do that? We use something called the release train. So let's say that we merge some commit into the default branch, and we merge a bunch of commits every day. Then at the start of the day, we will release a nightly version, which will contain the last merged commit. And the great thing about those nightly versions is that they can be very easily installed with a tool called RustUp by anyone in the world. So if I merge a pull request in Rust today, starting tomorrow, anyone can download the compiler with this version, and they can immediately try to use it, right? So that gives us a lot of experimentation in the ecosystem, and a very quick way for users to provide us feedback, right? We don't need to wait for 3 years before someone can try a feature. And we do these nightly releases essentially every day. So this is the nightly release channel. Then we have the beta release channel. So every 6 weeks, we will branch off a beta release. And this will not receive any new commits, apart from hotfixes, backport, and so on. And people can try this beta channel on their CI to see if it works or not. And after 6 weeks, this will become the next stable Rust release, right? And then again, we will branch a new beta. It will be again without changes for 6 weeks. People can test it. And then we will branch out another stable release, right? And this goes on and on. This has a couple of benefits because it's very predictable, right? We have a new stable release every 6 weeks. And the great thing about it is that it's not a big deal if you miss a release, right? If you really want to land something in Rust 192 and you try hard to do it, and you don't make it in time, it's no big deal. You just wait 6 weeks and you have another attempt, right? So this actually reduces the stress for contributors because there's essentially no deadlines, no artificial deadlines for landing usual stuff in Rust. And one thing related to deployment is also our backwards compatibility policy, which is very important to us. So Rust keeps backwards compatibility back to 1.0, which was released 10 years ago in 2015. modulo some very small things like bugs, essentially, in the type system or the compiler. And how can we be sure that we are backwards compatible? Well, we test it. We have a tool called Creator, and essentially, for every stable release, or when we want it, we will test essentially all the open source Rust code that we find online on GitHub or Crates.io, which is our package manager. And we will test, like, did it compile with the previous version? It has to compile with the new version too, right? So literally compare if it still compiles after we make a change. And again, we have some tooling. We have a Creator bot that allows us to say, like, please test this pull request on the whole ecosystem. And then maybe like 1, 2, 3 days later, it takes a lot of time, it goes back to us and tells us like how many crates or libraries were regressed. It gives us this nice UI so we can actually see like what was the compilation error. And when we triage this, there are essentially two things that can happen. Either the change is so majorly breaking that we cannot land it immediately, and then we need to actually wait those 3 years before the next Rust edition. Rust editions are a way for us to make backwards incompatible changes that are opt-in. So they won't break the ecosystem. People have to opt into them when they need, and they can do it on a project-per-project basis. So that's the first option. The second option is that the breakage is not actually like so big, so terrible. So then we will usually land it, but also we will go out of our way to send pull requests to all the affected crates and fix them so that they compile both with the old and the new version, right? And this can be a lot of work. Like, it can be like tens of crates that we need to go and fix so that they still work with Rust. But I think that is super valuable because it builds trust between the Rust project and the community, and they can trust us that we won't essentially break their code. So that was deployment, and now the last part is about maintenance, which is, in a way, the most important part. Like, if you take a look at the GitHub profile of the average like open source or Rust developer, you will see that they spend a lot of time on GitHub. But what is maybe not so obvious is that, like, it's not just programming. Like, there's a very large part of this that has nothing to do with programming. I really like this slide from Daniel Stenberg, who is the maintainer of curl, probably one of the most successful and used open source libraries in the world. And he shows that doing maintenance is doing a lot of things. It's like triaging issues, doing pull request reviews, writing documentation, writing tests, fixing CI, communicating with users, release management, blog posts, finding sponsors, doing conference talks. And then maybe at the end of the day, if you have like some time left, you can do the actual fun stuff, which is like implementing new features, right? And optimizing performance or whatever is like whatever you enjoy. But you also need to do all those other things to actually keep the project running. And maintaining stuff is really hard. Like, we have about 300 repositories in the Rust project. And if you remember that if we have like 300 people, that's almost like one repository per user. And some of those repositories have like tens or hundreds, thousands lines of code. And some of those volunteers, or actually most of them, are unpaid, and they work like a few hours per week on Rust, maybe. So it's actually a lot of work to keep this running. And it's also unglamorous work, right? Like, doing open source maintenance or any sort of software maintenance is like doing house chores, right? It's like cleaning the dishes or vacuuming or making your bed. No one wants to do it, but it is crucial work. It needs to be done. Otherwise, your home or your software project will become a big mess. And the problem with maintenance is that there is this sort of imbalance, right? Like, if you are a fan of Star Wars, you might know this rule of two. And always, when you have on one side someone that implements a new feature, you need to have someone else on the other side that will do the code review, that will maintain the feature for the next 5 years, that will do the refactorings necessary to even unblock landing this new feature, right? And the issue is that actually there is a lot of implementers. Like, even in open source projects, there is usually quite a lot of people that want to contribute something new, but the number of maintainers that then have to take this new thing and, you know, live with it for the next X years, that's usually much smaller. So there is also why recently there have been various initiatives started to essentially try to find money to pay full-time maintainers of Rust, of the most crucial things in the Rust ecosystem, for example, like the compiler or things like that, because I think it's really like needed. Like, we need money to pay the people that maintain stuff. Otherwise, this process just won't be sustainable going into the future. I couldn't have an open source talk without showing this timeless ESKCD comic. It's I think, quite popular, but it's just so true, right? Like, for me, open source is the foundational infrastructure of, like, essentially the whole modern digital world. And Rust is actually becoming a quite important part of this infrastructure. And for me, doing open source maintenance is like building tools that are used by someone else to build another tool that is used by someone else to build an app that will do something interesting. So it's like if you are building a screwdriver that was then used to create a wheel that will be used to assemble an ambulance, and that ambulance might one day drive a doctor to a patient and save their lives. But no one knows that there had to be the screwdriver at the beginning, otherwise this whole process could, like, not work, that you built the wheel in the wrong way or the ambulance didn't reach the patient in time. So if we make, like, even very small improvements in this foundational layer, I think that they can sometimes translate to, like, very magnified benefits at the end of the road. So from my view, open source maintenance is really crucial. Now, let me end this talk with asking you a question. Do you depend on open source? Yes, you do. Of course you do. If you have any sort of electronic device, you are depending on open source, whether you know it or not. If you are a programmer, that's even much higher dependence than, like, let's say, regular people. So if you do, think about trying to give back. There are a lot of ways to contribute to open source. Like, of course, the obvious ones are, like, creating an issue, go to the GitHub repository, describe some issue that you have. Or even if you fix a bug or implement a new feature, upstream it to the repository so that other people can use it. Improve documentation. If you use some package and you find something weird in the documentation and you spend some time on it, well, try to send a pull request that will make it better so that the next person won't have to spend time on understanding something that might not be completely clear, right? But there are other ways, like just discussing things, writing blog posts, talking to people at a conference about your favorite open source software. That's all very valuable. And also giving credit. Like, there are essentially all companies use open source. Some of them don't, like, attribute the software. Some of them even try to hide it, which is actually kind of a shame. And most importantly, be kind. Like, whenever you interact with people of open source, like maintainers of open source software online, try to be kind to them, right? Like, as I said, it can be really hard work. It's usually unpaid, and if you want to ensure that the people will continue maintaining this software, the least you could do is actually, like, interacting with them and being kind and not treating them as someone who has to do some work, who has to fix your bug, who has to implement your feature, right? And of course, then we have the elephant in the room, which is actually, like, sponsoring maintainers with actual money, which is a very touchy topic. And of course, I understand that not everyone wants or can contribute with money. That's perfectly understandable. And sometimes it might not even be, like, clear what to do. So there are some initiatives like thanks.dev or Open Collective or commands like npm fund that allow you to essentially automatically split some number of money across all the open source libraries and dependencies that you depend on. And of course, you can also use services like Patreon or GitHub sponsors to sponsor, like, individual contributors that work on some package that you enjoy. And even better than contributing yourself is, like, talking to your team lead or boss or your company and saying, like, hey, we depend on this really crucial open source library that is maintained by this poor student from India. Maybe we could give them some money to make sure that they will continue maintaining it because we depend on it, right? Like, so, like, let's say $50 per month is almost nothing to most companies, but to an open source contributor, it can really be a very important thing. And even getting the signal that someone appreciates their work can be the difference between continuing maintenance or just marking a repository as archived and never touching it again. So that was pretty much all I wanted to say here. As a recap, Rust does everything in an open source way. And I love that, and I'm very glad that I can be a part of it. And if you take one thing away, it's to build tooling to help you reduce stress and make your life easier, and maybe try to appreciate and sponsor your open source dependencies. If you liked what you saw, you can drop by our Tulip and say hi. And if you'd like to learn more about the Czech Rust community, we have this website called rustlang.cz. where you can see like the Rust meetups that we have and talk recordings, learning materials, job postings, and so on. So yeah, Rust is open source equals love. That's all from me. Thank you for your attention.
Okay, we have 4 live questions. The first questions is, what is your outlook on Rust long-term positions in modern software stacks?
So as I said, I think that Rust is playing a bigger and bigger role in open source foundation infrastructure. Like if you take a look at the metrics, like number of libraries, number of downloads of those libraries, it has been growing exponentially for the past 5 years, right? And having an exponential growth for a few years kind of shows something. It is being used by a large number of companies, and it is increasing every day. And especially the foundational software is actually being often like either rewritten or extended in Rust to gain memory safety, which some people might shrug that like, oh, memory safety, like who cares? But memory safety can actually be the difference between life and death. Like if you have a car or an airplane or a medical device that runs into a memory error in the middle of doing something dangerous, like driving, that can really be a big problem. So, I mean, obviously, I'm positive about Rust. I think it will become more and more used in the world, and especially in this foundation infrastructure. And I would also like to say, like, some people still think that Rust is like niche. I think 2 years ago, I was still like saying, yeah, it's like at the edge of the mainstream languages. Today, like Rust is a mainstream language. Like if you take it at any of the like published metrics, it's like next to Kotlin and Golang, right? Like it's essential. It's even being like it has more users than Kotlin and Ruby and slightly less than Go. So Rust is mainstream language. I think is here to stay.
Okay, next questions. Martin Luhoš, how many hours per week do you spend on the Rust project? Do you get any financial compensation for it?
Yeah, so I'm actually one of the lucky people who are paid to work on Rust. This wasn't the case from the beginning. Like I spent a few years contributing in my free time, but for the past, I think, 2 years, I'm actually being sponsored by a company. I mean, I essentially work on Rust full-time, more or less, but as I showed before, I also teach and do some other stuff, so it's not like completely full-time. So maybe like 3-4 days out of the week, and I'm essentially paid for all of that.
Okay. Anonymous, when you bundle multiple pull requests into one to save cost, how do you handle pipeline failures?
Well, yeah, that's a very good question. So if the rollup fails, we will essentially take a look at the failure and try to like estimate which one of the pull requests failed CI. We will remove it from the rollup and we will try again. So we actually, I didn't show this, but we have some mechanism of marking pull requests as being like dangerous to roll up or very safe to roll up. Like if it's a one-line change of some like fixing a typo in a markdown file, we say that always roll up this pull request. If it's like a 1,000-line diff that modifies some important part of the compiler, we will say never roll up this pull request because the chance that it will fail CI is pretty high. Currently, this is like a very manual process, but we are thinking about introducing some light amount of data science, maybe AI, to like help automate this because it is very data-driven, right? Like we have data for the past 15 years about what CI failed or succeeded. So we have actually quite a lot of data, and maybe we could make some data science problem out of it and make a bachelor thesis for some student or something.
1, 2. We have time only for one last questions, but if you need any more questions on or talk with Jakub, wait for him after his talk, and you can speak with him. The last questions from Piero is, do you think it's possible to keep testing against the whole ecosystem in the future? And how does the growth looks like in recent years?
Yeah, so as I said, the number of crates and Rust projects that keep appearing every day is like exponential, which is actually causing us a lot of issues in the infrastructure team. The crater bot, I mean, yes, it is an issue. As I said, it can take a long time before we test everything. But in a way, it's also a very scalable problem. Like we run this crater on the cloud, and with a click of a button on like, I don't remember if it's like Azure or AWS, but somewhere, we can essentially scale the machines as much as we want. Of course, then we need to pay for it. So right now we have like some credits from the major cloud companies that sponsor this kind of work. So as long as those companies will give us enough credits, we can continue doing this. Maybe in the future we can consider like, I don't know, maybe we can ignore libraries that were published like 10 years ago and no one downloaded them in 5 years. Maybe we don't need to like test really everything that we find. But so far we really try to test as much as we could.
Okay, thank you for your talk.